Hello everyone, Aaron here. Welcome back to Leetcode. Today we are doing the binary tree pruning problem. Given the root of a binary tree, return the same tree where every subtree of the given tree not containing a 1 has been removed. A subtree of a node is node plus every node that is a descendant of node. Okay, so here this subtree does contain a 1 because there's one here, but this subtree does not contain a 1, so it gets cut off. This one here, this entire subtree, there's no 1s here, whereas this one, we do have a 1, so we keep this, but we get rid of this because there is no 1 in the subtree. Okay, this is your standard sort of recursion problem, I suspect. It's just going to be a case of can I wrap my head around it? Okay. So what's the way to think about this? If root dot, in fact, what I want to do is I want to do self dot prune tree. That's not what I wanted to do. New left is self dot prune tree of root dot left. New right is self dot prune tree root dot right. Basically, if new left is none and new right is none, in fact, hang on, just before, if root is none, return none, just before we go any further, and self.val, and root.val does not equal 1, return none. Otherwise, I want to return a tree node with root.val new left, new right. Does that work? It almost seems too simple, but I think I followed that one mostly on gut instinct rather than any particular overarching theory. So let's see if it works. The prune tree, if the root is none, we're done. New left, we want to go down and try and prune the left. There's no left here, so this is going to be none. The right, we're going to have to now go down and prune. This here, is this a none? No, it's not. Going down and prune the left. Is this none? No, it's not. It has no left, it has no right, and it itself is not a 1, so we're going to turn this into a none. So up here, new left is none. We now go down and do the right. This is none, the left is none, the right is none, but the value itself is 1. So we're going to return a tree node with the none, none, 1 in it. Come back up. New right is not none, so we're going to do a tree node with the new left, which was none. New right, which is not none, and its value, which is the same. We're going to come back up here. The new right is not none. New left is none, new right is not none, so we're going to return a new tree node with the new right. I think that worked. Example 2 we'll quickly do. We go down on the left, This thing is going to get pruned because it's a 0. This thing here is going to get pruned because it's a 0. This thing here has no children anymore, so it gets pruned because it's a 0, and so on and so forth. Now, the node.value is either 0 or 1, so that's fine. It doesn't matter. We were just checking for 1 anyway, rather than 0 or 1. And the number of nodes is never going to be very big, so this recursion... there's a chance we will bust this recursion. In fact, no, there isn't. No, what am I saying? We will never bust this recursion because the recursion can call up to about roughly 1,000 layers deep. I think it's like 998 layers deep. We can only go down to 200 layers deep. So we are absolutely fine to use recursion for this problem in Python. Let's run the code. I'll just hit submit. I didn't want to do that. I haven't done my typo check. Typo check passed. Let's actually run the proper test cases now. Looks good. My god, my instincts must be pretty decent because, as I said, I kind of did that one on instinct rather than actually thinking. Let's submit it. Let's see what happens when they give me an actually hard one to fight. Oh, perfect. Surprisingly fast too. Don't quite know that. I imagine this is one of those everyone's done it the same way, so we're near the middle of the pack. Same with the memory use. Everyone's probably done it the same way, so we're near the middle of the pack. This is a standard depth first search recursion as well, so we could have maybe made our own stack to, one, work with bigger trees, and two, maybe avoid some function call overhead. That's all details. We did it. Problem solved. Fantastic. I think that's it from me. Do remember to like, comment, and subscribe. In particular, if there's a problem on Leetcode you'd like me to have a go at, do leave a link down in the comments, and I'd be more than happy to do a video on any special requests. Other than that, have a good week, and I will see you next time. Bye.